Hi friends, in this video let us understand the basic concepts of module 3, partial differential equations. In short it is called PDE. So the basics, what are the basics you should know so that easily you can understand all the concepts in PDE. So now let us start with the basic concepts. So ordinary derivative. So what do you mean by ordinary derivatives? So we know if y is function of x, means y equal to f of x, y is dependent on x, or y changes as x changes, which can be written as change in y with respect to change in x, dy by dx, and also we write it as d square y by dx square, d cube y by dx cube, and so on. So these are all called ordinary derivatives. In the same way, what do you mean by partial derivatives? Partial derivatives. So whenever a z is function of x comma y, if suppose z is equal to f of xy, or z function of x and y, or we say z is changes or varies as x changes, z varies as y changes, which can be expressed as dou z by dou x, dou z by dou y, change in z with respect to x, change in z with respect to y. So these two are called partial derivatives. Dou z by dou x, dou z by dou y are called partial derivatives. So now let us know about some basic examples. So example, so z equal to x square plus y square plus 3xy. If this is the example, what is dou z by dou x? Dou z by dou x means differentiate z with respect to x. With respect to x means x square differentiation 2x plus y square. Y is other variable. So whenever we are differentiating with respect to x, treat y as constant 0. Now 3y is constant and x derivative 1, so 3y, 2x plus 3y. Dou z by dou y, differentiate z with respect to y. When you are differentiating with respect to y, treat x as constant. So derivative of constant is 0 plus 2y plus, now with respect to y means 3x constant, y derivative 1, so in plus 3x. This is what we get. So if you consider another example, z equal to e raised to 2x plus 3y. So what is dou z by dou x? So here, so e raised to any x differentiation, e raised to x, e raised to 2x plus 3y. With respect to x means multiple of x is 2, so that you have to multiply. So dou z by dou y. Differentiate z with respect to y. So e raised to some y means e raised to 2x plus 3y. So multiple of y we need to consider. X is constant, so multiple of y is 3. Now similarly z equal to sin xy. So derivative dou z by dou x. Differentiate with respect to x. Sin xy differentiation, sin differentiation cos xy. With respect to xy, x is variable, so xy differentiation y. Dou z by dou y. So here sin differentiation cos xy, with respect to xy, y derivative 1, so x multiplied by x. So this is how we can understand the principle of partial differentiation. So that is, whenever you are differentiating with respect to x, treat y as constant. Whenever you are differentiating with respect to y, treat x as constant, is the general principle of partial differentiation. It means, so whenever we are differentiating with respect to one variable, treat all other variables as constants, is the general principle of partial differentiation. So already we know ordinary derivatives. So that is dy by dx, d square y by dx square, d cube y by dx cube are called ordinary derivatives. So what do you mean by ordinary differential equation? It means the differential equation which contains ordinary derivatives is called ordinary differential equation. So for example, so dy by dx plus y equal to 0, d square y by dx square minus y equal to x square plus e raised to x something. So these are all, both are examples for ordinary derivatives, because both equations are having ordinary derivatives. So now you look at this one, it is having only y and derivative of y and derivative of dependent variable y. So it is called homogeneous differential equation, homogeneous ordinary differential equation. So similarly, so if you look at this, it is having y term, dependent variable, and also independent variable x. So it is called non-homogeneous differential equation. So now it is all about ordinary differential equation. Now let us understand what do you mean by partial differential equation. The differential equation which contains or which involves partial derivatives is called partial differential equation. In short, it is called PDE. So the partial derivative means it should involve terms like dou z by dou x, dou z by dou y, dou square z by dou x square, dou square z by dou y square, and so on. For example, so let us consider these examples. So now dou z by dou x plus dou z by dou y equal to 0. So it is also partial differential equation. Another example, dou square z by dou x square plus 2 dou z by dou x plus z equal to 0. Another example, dou square z by dou x square equal to x plus y. Another example, dou square z by dou x dou y equal to x square plus y square. So these are some examples for partial differential equations. So now let us make out the difference between all four examples, first two and last two. So here, so when you look at first example, z, so we know z function of xy, z dependent on xy means z is called independent variable, x and y are called z is called dependent variable, x, y are called independent variables. So now dependent variable z, first equation is having z, dou z by dou y, dou z by dou x, derivatives of z, only dependent variable. Second example, z, derivative of z, derivative of z. So first two examples are having only one term z, z and its derivatives. It is called homogeneous PDE, homogeneous partial differential equation. So now look at next two examples, z, derivative of z, derivative of z, dou square z by dou x square, derivative of z, z is there in this PDE, but along with that x and y, independent variables, it has x and y. So here also dou square z by dou x dou y means derivative of z, and also it is having independent variables x and y. So both dependent and independent, both derivatives, both variables, if it is having, it is, these two examples are called non-homogeneous PDE. So further, what we are going to learn in this module is how to solve homogeneous PDE, how to solve non-homogeneous PDE, which method we apply. So that concept only you are going to learn throughout this module, partial differential equations. So here you must know certain notations. If z is function of xy, z is dependent on xy, then we get change in z with respect to x, change in z with respect to y. Those are denoted by dou z by dou x and dou z by dou y. So these are derivatives, partial derivatives. Similarly, again if you differentiate, you will get dou square z by dou x square. Again with respect to y, dou square z by dou y square. So dou z by dou x with respect to y, dou square z by dou x dou y. So these are all called first order and second order partial derivatives. So here dou z by dou x is also denoted as zx, and this is zy, dou z by dou y, zy, dou square z by dou x square, zxx, dou square z by dou x dou y, z xy, dou square z by dou y square z yy. So these are some notations and which we use while solving problems. Along with this we are taking certain notations to avoid writing dou z by dou x, dou square z by dou x square, all these things. So those notations are, it will start with p, dou z by dou x p, dou z by dou y q, dou square z by dou x square r, dou square z by dou x dou y s, then this one t. So p, q, r, s, t are the notations for first order and second order partial derivatives while solving problems which we use these notations.